Hello, guys. Welcome to Science Exam Clinic. Forgive me for this is my first time making a video like this, and I'm pretty sure we'll be having a nice ride together. So yes, welcome once again. My name is. Do I need to tell you my name? But yes, my name is Abdul Latif, and welcome on board with me while I explain this in a better way, or rather in a simplified manner. So yes, what is mole? A mole is the amount of substance that contains 6.02 times 10 raised to power 23 particles. I also refer the 6.02 times 10 raised to power 23 particles as the Avogadro's constant. Yes, and where do we get mole? Atoms and molecules are so tiny that counting them one by one is impossible. So we then need a bridge between the microscopic word atoms and microscopic word grams. So the mole is that bridge. So hence why we have what we refer to as also we also know that our one mole is officially defined as the number of atoms in exactly 12 carbon of 12 grams of carbon. Sorry, that's 12. And molar mass, this is the weight of 1 mole of a substance. You can find this on the periodic table. Yes, that is 1 weight of the substance. Carbon's atomic mass is 12. 1 mole of carbon weighs 12 grams and whatnot. But yes, how then do we get this molar mass? There's a cheat to which we have it. So what we do is we get the atomic number that is, let's say for oxygen now, oxygen is 8 in the periodic table, and then 8 multiplied by 2 gives us the atomic mass number. But the cheat there is for the ones that are what do you call this, even number now. Yes, you multiply them by 2, and for the ones that are odd number, you multiply them by 2 and then you add 1. Like chlorine now, chlorine is 17 in the periodic table, and then you multiply by 2, that gives you 34. Then addition with 1, although there's an exemption and doesn't really work for all atoms, but it works most times. Like we have our sodium now, we have our sodium to be 11, and 11 multiplied by 2, that will give you 22 plus 1. So the atomic mass number for sodium is 23. So yes, that's how you get the molar mass. So yes, now for the mole, for this mole now, we have mole is equals to mass in gram over relative molecular mass, or rather mass in gram over the molar mass. Okay, so yes, we have few examples here. We have how many moles are in, oh sorry, there's a mistake, how many moles are in carbon dioxide, CO2, and I would think that should be how many moles are in 12 gram of carbon dioxide. I'll make a correction to that. And then the second question says you have a sample containing 3.011 times 10 raised to power 23 atoms of gold. How many moles is this? Then the third question, how many moles are present? How many moles is present? How many moles are present in 44 gram of sodium hydroxide? Well, like I said, this is my first time doing this, so yes, you would expect this error. You don't expect that I'm perfect, right? But yes, like I said, this is going to be a very good ride for us. And yes, the fourth question says how many atoms of oxygen are present in 9 gram of water, that is H2. So yes, work with me as we go to the solution. So the first one, if you recall, it says that we call number of moles equal to mass in gram over molar mass, and then our molar mass is 44. Okay, the mass we were given, the mass in gram, 44 gram of CO2. Yes, it was 44 gram of CO2. And then the molar mass, how then do we get our molar mass? We get for different atoms now, we have 12 plus 16 times 2, that is, we have 1 carbon and we have 2 oxygen there now. So that becomes the molar mass multiplied by the number of atoms you have there. So that's 16 times 2 because we have 2 atoms of oxygen and then 1 carbon. Yeah, so that gives us in total 44 grams. So number of moles equals 44 by 44, and then number of moles equals 1 mole of carbon dioxide. Yes, and then the second question, number of mole is equals to, also just also another formula, number of mole is equals to number of particles over Avogadro's number. So our number of moles is equals to 3.011 times 10 raised to the power 23. And if we recollect earlier, I said 6.02 times 10 raised to the power 23 is our Avogadro's constant. So number of moles equals to, once you divide that, you have 0.5 moles of gold. And then the third question says, we are calculating number of moles of sodium hydroxide. So like we did in the first question, we are given mass 44 gram, and then our molar mass, just like we did earlier. Molar mass for sodium is 23, oxygen is 16, and then hydrogen is 1. If you recall, if you see now, you see we don't have any coefficients, so that simply means we just have just 1. Neither do we have any subscript, neither do we have any subscript. So that's 23 plus 16 plus 1 equals to 40. So slotting in our values, we have 44 divided by 40, and number of moles equals to 1.1 mole of sodium hydroxide. And then the fourth question, the molar mass of water is 18 gram per mole, that is 2 hydrogen. So that's 1 times 2 plus 16, that gives us 18 in total. And if you have to go by the number of moles equals to 9 gram divided by 18, that gives 0.5 moles of H2. So because we are calculating for oxygen now, that is how many moles of how many moles of oxygen do we have there? Yes. So we then do this, count for the number of molecules, that is 0.5 moles multiplied by 0. Multiplied by 6.02 times 10 raised to the power 23. This gives us 3.011 multiplied times 10 raised to the power 23 mole. And then you count the specific atom in 1 molecule of water, that is, and if you look at water now, we have H2, we have just 1 oxygen there. So then you divide by 3.011. So sorry, then that should be 3.01 times 1 atom of oxygen. If it was 2 atom of oxygen now, that would have been 3.011 multiplied by 2 atom of oxygen. But since we have just 1 oxygen in water, that gives us 3.011 times 10 raised to the power 23. I hope this was pretty explainable, and if there's any question, you may wish to throw the question to me via the. Have a nice day.